Here we can focus directly on the input neurons, the Schaefer collaterals ending on the CA1 pyramidal cells. We now see on the right-hand side, this is the postsynaptic cell. Notice we're now focusing on the postsynaptic cell. The early change for explicit memory storage is going to have a postsynaptic target rather than a presynaptic target. The Schaefer collaterals come in, they release glutamate, just as we saw in the sensory neurons in aplysia. They act on two different kinds of receptors to glutamates. A receptor called NMDA receptor and a receptor called the AMPA receptor. Under normal circumstances, only the AMPA receptor is active. But if you give a train of stimuli, the NMDA receptor becomes active. It fluxes calcium, allows calcium to come into the cells. Calcium activates a second messenger kinase, but a different one than the cyclic AMP-dependent protein kinase, a calcium-sensitive kinase called the calcium calmodulin-dependent protein kinase. It acts by inserting additional AMPA receptors into the postsynaptic cell. And that is the mechanism for short-term synaptic plasticity in LTP in the hippocampus. A postsynaptic mechanism involving CAM kinase inserting new AMPA receptors.